Fantastic with Professor Michio Kaku. In this hour, we're talking about a new book called Strange New Worlds about the discovery of extrasolar planets. But before I begin, first of all, let me say thank you for all those people that attended my book tour. I just finished a 10-city book tour throughout the United States, and it's because of you, the listeners out there, that propelled the book onto the bestseller list. It's been on the New York Times bestseller list now for 1 month. Physics of the future. How will we live in the year 2100? What about medicine? What about biotechnology? What about space travel? What about computers, robots? These are scientific discoveries as told to me by 300 of the world's top scientists that I've interviewed for BBC Television, the Discovery Channel, the Science Channel, and Science Fantastic right here on 130 radio stations across the United States. So once again, thank you for making Physics of the Impossible a bestseller, and we still haven't finished the book tour yet. So go to my website, mkaku.org, mkaku.org, and find out about the latest about my new book, Physics of the Future. But once again, in this hour, we're talking to Ray Jayawardena. He's a professor of astronomy and astrophysics at the University of Toronto, and he was named to Canada's top 40 under the age of 40. The book is called Strange New Worlds, about the discovery of extrasolar planets. When we last left off, we were talking about the Kepler, which is a satellite in outer space. The latest result I heard shows that Kepler estimates that 1 out of every 200 stars has a habitable Earth-type planet going around it, possibly with a liquid ocean, in which case there are perhaps 500 million planets in our galaxy which are Earth-like. 500 million. Given that huge number, do astronomers therefore think that life is common throughout the universe?
Well, the odds are certainly in favor of it. There are some 200 billion suns in our galaxy, and as you said, the first estimate of how many habitable planets there are puts it already at 500 million or more. So the numbers, habitable worlds, numbers of places in the galaxy alone where there could be life is certainly staggering. And then we also know that ingredients of life, the stuff of life, is common in outer space. Now the question is whether that means life itself has originated and evolved elsewhere. And we're getting closer, tantalizingly close, to being able to ask and address that question in a serious way. Already, for some of the bigger planets, from a distance, we're already able to measure the temperature of their atmosphere, to be able to tease out fingerprints of various interesting molecules in their atmospheres. Now, if only we could do that with smaller, more terrestrial planets, if we could tell what their atmospheres are made of, what sort of conditions prevail in their atmospheres, then we'll be much closer to identifying so-called biosignatures, or molecules that we tend to associate with life here on Earth, to see if those are common elsewhere as well.
Now, let's say that we zero in on a twin or near twin of the Earth in outer space. Once the Kepler satellite has located such a planet, then what's next? We analyze the atmosphere. What chemicals do we look for that are the biomarkers of life, like oxygen, water? What do we look for?
Indeed. So one issue with Kepler, though, is it will be fantastic at giving us good statistics, but many of the planets it finds will be around stars that are too far away, that they're too faint for us to be able to do very good follow-up observations. On the other hand, there are a number of ground-based searches happening where people are targeting some of the nearest stars in the sun's neighborhood in search of planets seen in transit, seen to pass in front of these stars. So if we have a few really nearby examples of terrestrial worlds or planets that we call super-Earth, planets that are a little bit bigger than the Earth, that may have rocky surfaces and interesting atmospheres, those will be the ideal targets for a detailed characterization, for searching for these biosignatures. The kind of molecules that people have talked about are things like oxygen, ozone, methane, water vapor.
Okay.
Those are the kinds of biosignatures that we would be looking for. But it's challenging because we only know of one kind of life, and that's all we know what to look for. But life elsewhere could be rather different.
Okay, well, let's take a short commercial break, and after the break, we're going to continue our discussion of strange new worlds and the possibility of one day discovering life in outer space. Give us a call. The hotline number is 866-323-2538, and you're listening to Science Fantastic with Professor Michio Kaku. Give us a call. A planet out there that has the ingredients of life and maybe even extraterrestrial life emitting radio emissions. But isn't it true that because the stars are so far away, that a two-way communication is impossible between them, because it would take decades, if not centuries, for a message to go between us and them and back again?
Yes, two-way communication would be rather challenging. Now, there is a big difference, though, between finding biosignatures, these molecules that we associate with life in the atmosphere of a distant world, and actually detecting an artificial radio signal. Here's the difference. In the first case, we wouldn't really know whether we're talking about slime or civilization. We wouldn't know what kind of life is at the other end. On the other hand, if we were to detect a radio signal or some other electromagnetic signal of artificial origin, then even if we can't decode it, even if we don't know the contents of the message, we already would know that there's somebody intelligent at the other end. We would know that there is life with technology at the other end. So I think that would be a lot more dramatic. It would have perhaps a more immediate impact on our thinking about our own place in the universe, even before we can decode it, even if that takes a decade, even before we are, as you say, because of the distances involved, long before we have a chance to have two-way communication. Just the fact that there is life out there that is in control of advanced technology, I think might affect us in much more dramatically and much more immediately than indirect evidence of a planet teeming with life, where we don't know what kind of life it is. We don't know whether it's rather primitive organisms or whether it's an advanced civilization.
Well, on Science Fantastic, we had Dr. Seth Shostak, a physicist with the SETI project, and he told us on radio that he expects within 25 years for us to make contact with intelligent life in outer space. Do you think that's boundless, groundless optimism? Or do you think that, hey, maybe there's something to it? More radio telescopes, more planets being discovered, 1,000-fold increase in our knowledge just within the last few years. Any thoughts?
Well, I mean, I think a lot will depend in that case on funding and technology. Unfortunately, we learned just this week that the Allen Telescope Array, which the SETI scientists use in Northern California, scientists at the SETI Institute use to listen to radio signals from other star systems, has gone into hibernation for the lack of funding, and it might even be shut down. So
that's right? Oh.
Yeah, that's
bad news.
Just this week.
Okay. Ray, we have to take a short commercial break, but after the break,